right, now let's talk about adding, subtracting, and multiplying polynomials. You can follow along on page 126 in your workbook. We are going to start off with multiplying because this is the information that's the newest, and then the other one is going to feel like review. So let's talk about multiplying first. Whenever you're asked to multiply polynomials, it's going to feel like you have done this before. It's just going to, maybe it looks a little more complicated as we go, but the way that you multiply is you're going to distribute and combine like terms. So in example A, I'm going to multiply by distributing. So I'll distribute the 6n squared to n squared. I'll have 6n. Now, what do I do with these exponents? You add them. So whenever you're multiplying and you've got the same base but different exponents, add the exponents. So this would be 6n to the fourth. 6n times n would be plus 6n cubed. 6n times 3 is plus 18n squared. Then I need to distribute this negative 7. So negative 7 times n squared is minus 7n squared. Negative 7 times n is minus 7n. And then negative 7 times 3 is negative 21. So then I just look for and combine like terms. So let's see, any 6x to the fourths? No, but I'm going to highlight the n squareds. Those are like terms I can combine together. So this would look like 6n to the fourth plus 6n cubed plus 18 minus 7 is 11n squared minus 7n minus 21. So it feels the same, just now our polynomials are a little longer. Now multiplying 3. Whenever you have to multiply 3, in this case we have 3 binomials we're going to multiply together, you only multiply 2 factors at a time. So let's think about numbers. Let's say I was going to multiply 2 times 8 times 6. I would not multiply 2 times 8 and 2 times 6. I would multiply 2 times 8 first to get 16, and then I would multiply 16 times 6 to get, let's see, that would be 60 plus 36, 96. So the same, I'm going to do that the same way, but with algebra. So I'm going to multiply these two together first, then that product is going to get multiplied by the third one. So let's multiply mn plus 1 times m squared minus 1. So mn times m squared n. Now again, you're just going to add exponents. So m times m squared is m cubed. And n times n is n squared. Then mn times negative 1 is minus mn. 1 times m squared n is plus m squared n. And 1 times negative 1 is minus 1. So this product gets multiplied by mn squared plus 2. Sometimes after you multiply, you might have some like terms, but right now I notice everything has a different exponent. Even though I have the same letters, I've got different exponents, so I can't combine. So now it's just time to multiply. Let me get rid of these marks. Okay, so m cubed n squared times mn squared. M cubed times m is m to the fourth. N squared times n squared is n to the fourth. Then I'm going to multiply this by 2, and I get plus 2m cubed n squared. Then we're going to multiply the negative mn times m squared, mn squared. M times m is minus m squared n to the third power. Negative mn times 2 is minus 2mn. Then I need to multiply m squared n times both. So m squared n times n is plus m cubed n cubed. and then m squared n times 2 plus 2m squared n. Then finally, I need to distribute this -1, so I'll just do minus m n squared minus 2. Then I look to see if there are any like terms. Now, for it to be a like term with m to the fourth, n to the fourth, it would have to be m to the fourth, n to the fourth, and that would be a like term. It'd have to have both an m to the fourth and an n to the fourth. And that's not happening. Do I have any m cubes and squareds? Nope. Do I have any m squareds and cubes? Nope. Don't have any other like terms. So here is my answer. All right, so now let's talk about adding and subtracting. To add and subtract polynomials, all you have to do is combine like terms. So I'm going to look for like terms. 4a to the fourth. Oh, no like terms there. So I've got 4a to the fourth. Okay, now let's see. -6a to the third plus 5a to the third is -a to the third. Oh, that's not going to work out. -a to the third. Then grab another color. -3a squared plus 7a squared is -3 plus 7 is plus 4a squared. Then I have an a plus a 2a is plus 3a. And then a +1 minus 2 is -1. So there is my answer. To subtract, you'll do the same thing. A lot of people like to, but you have to be careful with this negative. So a lot of people like to just distribute this and turn it into an addition problem. So I would have 2a squared b squared plus 3ab squared minus 5a squared b minus 3a squared b squared plus 9a squared b minus 7ab squared. Then I look for like terms. So let me grab a color. 2a squared b squared, for it to be a like term, the other like term would have to have an a squared and a b squared. So this one does. So 2 minus 3, combine those coefficients, I get -1 a squared b squared. Then like term with 3ab squared would also have to have an a to the first power and a b squared, which is right here. Those two are like terms. So 3 minus 7 is -4ab squared. And then let's get another color. There we go. A squared b and an a squared b. So -5 plus 9 would be plus 4a squared b. So now let's do a word problem. Turn to page 131. So we have a manufacturer, a foundry manufactures aluminum trays from pieces of sheet metal shown. Here it is. So what's going to happen is that the manufacturer is going to have like a rectangle piece of sheet metal, and then they are going to cut away the corners. So the corners totally go away, and then they fold it up So they would fold it on these dotted lines, and well, it's a sheet metal, so they'd bend it up, and it would make an open box. And let me grab a picture and show you. So they would cut the corners away, like right here, and then fold it up, and it would make like a tray. So this is like a box top, like a lid, an open lid, just turned upside down. So that's the shape that's going to be formed. So we need to figure out to represent expressions for the length, width, and height of the metal tray. So remember these parts are gone. Let me get black to kind of get that away. Okay, so this part, the whole thing is 14 inches. But if I cut away the squares, and each square is an x by x square, so this part would be x and this part would be x, and the whole length without the two x's, I could express as 14 minus 2 x's. That would be this length right there, 14 minus the 2 x's. Then if I were to come up with an expression for this part, I know that the entire side is 20, but the length of each part that gets cut away is x. So this green part I could express as 20 minus 2x. So the length would be 20 minus 2x. The width would be 14 minus 2x, like the width. Now we need the height. So if you think about it gets folded up right there, it comes from folding this tab upward. So the height would be x. So write expressions for length, width, and height of the metal tray. Done. Part B. Write and simplify a polynomial function v to represent the volume. Well, the volume of a rectangular prism is length times width times height. So my volume in terms of x, because I'm going to need to use formulas, would be the length, which is 20 minus 2x, times the width, 14 minus 2x, times the height, x. So it says simplify, so that means I need to multiply it out. So I'll multiply the first two parts together. So my volume in terms of x, 20 times 14 is 280. 20 times 2 minus 40x. Negative 2 times 14 is negative 28x. And negative 2x times negative 2x is plus 4x squared. Then that is still going to get multiplied by the x. But I'm going to combine like terms first. So 280 minus, let's see, 40 plus 28 minus 68x plus 4x squared. Then this x, bring down the x, but the x does need to get distributed to all three parts. So v of x would be 280x minus 68x squared plus 4x cubed. And if you put it in standard form, 4x cubed minus 68x squared plus 280. Then in part C, they've graphed the function, so we have to explain what's marked by the relative maximum. So they've marked the relative maximum, and the x value is 2.9, and the y value is 3.99. So remember, this is an equation for v of x. So the vertical axis is v of x. V of x stands for the volume. And x, where do we get x from? X is over here. X is the side of the square that got cut away. So size of square side, there should be a space in there, square side cut away. So how do we interpret this? We would say if you cut away squares size 2.7, what's the units on this? Inches. 2.7 inches by 2.7 inches. The tray will have a maximum volume of 339 cubic inches.